We are doing the chapter name aldehydes, ketones, and the carboxylic acid. Aldehydes, ketones, and the carboxylic acid. This is the chapter we are going to revise. So first of all, we must know about this. Again, I am revising for you. What does they have a common in? What do they have common? The group one group no is common in all the three functional group. So I would say aldehyde represented by this way, correct? Ketone also represented by this way, and carboxylic acid also represented by this way. Did you understand? Are you agree with me, Hridaya?
Yes,
So
ma'am.
if I tell the aldehyde symbol, I may write R and H. Right. There is an exception, one compound which is formaldehyde. Both the sides we have H in this. That is formaldehyde. But the one will be the alkyl group, other will be the aldehyde. So this is aldehyde symbol. Correct, Hridaya? This is aldehyde. And the second one is the ketone. Both the sides you have the alkyl group attached to it. Okay. Now, carboxylic acid may you can have one side alkyl group, okay, and other side you have OH group attached to it. Did you understand the difference between aldehyde, ketone, and the carboxylic acid?
Yes, ma'am.
Okay. So the difference you understood, and now the common what we have found is they all hold a one common group we call the carbonyl. So the magic here exists in the carbonyl group only. So you have learned the alcohol. Now from alcohol we will prepare aldehyde, will prepare ketone, these compounds. So you have learned from these compounds how do we prepare alcohol, either by the reduction, because we wanted to convert the C double bond O into CH2 and OH. So what did we do? We did reduction. Now we want this has to expand in the carbonyl group. So what will we do? Oxidation, right? Okay. Before taking you to the left right hand side, I will teach you the IUPAC nomenclature of all these. So let's begin nomenclature. Here all the carbon functional group, right? How it will be represented, RCHO. So this carbon will be considered carbon 1. Did you understand? This carbon will be considered carbon 1. This is R, C double bond O, R dash. So the least position will be given to this carbon wherever. So we will have the two symmetrical, one unsymmetrical, two types of the ketone, CH3, C double bond O, and CH3. Symmetrical ka matlab ki from this side, if you divide, you get the equal number of carbon. So symmetrical may rule goes same way, no worry. Any side you can start because this gets the least position. Did you understand, Hridaya? Symmetrical ka, this is the order. Unsymmetrical में one side you have more carbon atom. Suppose carbonyl group है यहाँ पर CH3. So you have to start now. यहाँ पे you need to pay attention. This from this side we should move. Why? Because this way we can give the least position to the carbonyl. So this is the way we need to select the carbon chain. So giving least position to the carbonyl, we have chosen this way and we given the least position to carbonyl. Did you understand, Hridaya?
Yes, ma'am.
Are you able to understand the numbering, how to do in the naming reaction? Next
Yes,
is the
ma'am.
carboxylic. This is symbolized RC. I'm just taken in a condensed form. So this also carbon considered as a one carbon. ठीक है? This is how numbering will be made. Naming के लिए suffix of this secondary is used as ALL. Got it? And this is used as suffix ONE1. Remember? And this is used as oic acid. Got it, Hridaya?
Yes, ma'am.
Rule goes as usual. Prefix number, prefix name, root word, okay, primary suffix, seeing the single, double, triple, and then goes to aldehyde, ketone, and carboxylic. So have a confidence and start now. We will do all together. Okay. Remember this functional group one by one separate I will take and then I will give you all together. Okay. Are you confident? Now,
Yes.
as I said, this is the first compound of aldehyde. So this is called the one carbon. Just meth, eth, prop, but, pent, hex, hept, you just recall in your mind. Okay. Number one carbon is meth. Number two carbon is eth. Number three carbon is prop. Number four carbon is but. So meth, eth, prop, but, pent, hex, hept. Okay. And the last three is October, November, December. Like that you can say oct, non, and dec. Is that clear? That doesn't come in our syllabus, but it's okay that you can just remember. Okay, this is the trick. Now, one carbon ke liye, what is the root word Hridaya? Meth. We do not have any prefix over here. Carbon bond, hydrogen, we don't have further carbon anyhow. So single bond hai carbon hydrogen ke beech mein, that is only considered. So AN will be taken. Correct. What is the functional group over here, Hridaya? Aldehyde. So what would be the suffix? Al. So E of ANE getting replaced by A. Did you understand?
Yes, ma'am.
Good. So this is how we do the naming. Now next one you try by yourself. The root word is there. Carbon 1, 2, 3, 4, 5. Meth, eth, prop, bute, pent. Yes, Hridaya, go ahead now. Rough note is there with you. Do quickly, Hridaya. Do numbering first. From which side I should go? They use some other device for the speaker, so that some other speaker, so that I can hear you, because your voice is very low, Hridaya.
Is it from right?
Yeah, fine, Hridaya. I'm able to hear you. No worry. Yes, Hridaya. Go ahead for the numbering. Do I need to go from right to left or left to right, Hridaya? How will I move?
Right to left.
Exactly. Very good. So this carbon is 1 and this carbon is 2. Now go ahead with the naming. How many carbons did you select over here while numbering, Hridaya?
Two.
2. So what will be the root word, Hridaya?
Eth.
Eth. Very good. So name goes eth. What type of bond exists between carbon and carbon?
Single bond.
So what will be the primary suffix, Hridaya, over here?
Al. Oh
Very
no.
good. An, exactly, an. Because alkane, na? So E will be dropped here. How will you drop the E? By adding? Tell the suffix, Hridaya. By adding?
Al.
Very good. So what is the name? Ethanol.
Ethanol.
Very good. Next one, will you try by yourself? Be confident, develop confident, then only you can do. Okay, don't think I am less. You say you can do it. Okay, by learning the trick. Now go ahead, Hridaya, quickly. See, the prefix also I have kept for you. You can do it. Yes. The rule will be as usual, Hridaya. There is no change in the rule. Only the thing you have to give the carbon 1 to aldehyde. That's all. And the functional group, since it is the suffix is Al. That's all you need to remember. Go ahead with the rule. So far, what we have tried. Yes, go ahead quickly, Hridaya. How do we go for numbering, Hridaya? Help me out with the numbering. Left to right, right to left.
Right to left.
Exactly, right to left. 1, right. How do I go? Straight or down? Selection. We can go anywhere, right, Hridaya? Both the ways we are getting same number of carbon. Okay, which is not selected, that is called the substituent. That is prefix. Now you see the prefix position, same order goes. Chalo, write the name. So what is the naming rule, Hridaya? Prefix number plus prefix name plus we go to root word. Root word means number of carbon. These are the root words. Okay. Then we go with the primary suffix. Primary suffix ka matlab ki that is alkane, alkene and alkyne. Then E will be dropped off this by adding secondary suffix. It will be dropped. So here the secondary suffix is ALL. Now you do. Go ahead now. This is the naming rule. What is the position of the CH3, Hridaya?
Two.
Exactly. So 2 hyphen, name of this is 1 carbon है तो methyl alkyl group it is, methyl alkyl. हाँ, tell 2 methyl. Go ahead next. Root word. How many carbons do you have?
Three. Prop.
Pro. Very good. Next. Primary suffix, you go ahead, Hridaya. Single bond, na, everywhere. Carbon, carbon only we check. No other bond. Carbon, carbon bond held with a single bond. So what will be there?
An.
An, very good. Suffix, secondary suffix. Alcohol, aldehyde के लिए, what is the secondary suffix? Can you see the screen? Al, right? Did you understand now?
Yes, ma'am.
Will you do by yourself without help? Next one. Do this one. Root words are written over here, Vida.
Is it 2-methyl butanol?
Very nice. 2-methyl butanol. Very good. Next one, Hridaya. So you are able to do the aldehyde. I hope you can do it now. Clear, Hridaya? Can we go now for ketone? If you say yes, then we can go ahead with the ketone. Otherwise, we'll do some problems of the aldehydes. Tell Hridaya, can we go for ketone?
Yes, ma'am.
Very good. So ketone ka suffix, do you remember? What is the suffix for ketone? Help me. This is the symbol. What is the suffix, Hridaya? ONE, 1. What is the suffix of ketone, Hridaya? Last में है ना यहाँ पे? This only we will take as the suffix. Is this easy?
Yes, ma'am.
Okay. Same rule, Hridaya. There is no change as usual. But only the thing is least position we should give to the carbonyl group. That's all. ठीक है? Let's start. So 1 carbon, 2 carbon, 3 carbon. You can go either right to left to right because ये symmetrical है. So we get the 3 carbon prop single bond between these two all hydrocarbon chain ANE will be dropped by adding ONE. It is clear, Hridaya, to you?
Yes, ma'am.
You can even write the 2-propanone or propane 2-1. Second position पे है ना double bond carbonyl group. So you can write like this. Second one. For unsymmetrical, you see. Just tell me how to do numbering, Hridaya, here. From which side I should go?
Is this also from
Least position given to, remember, functional group. Okay. So that is carbonyl ke sath applicable because this carbon cannot be considered one. Otherwise, this methyl will be left. Okay. Long carbon chain we need to select while selecting long carbon chain. Chalo. Tell me. How do I move, Hridaya? Left to right or right to left? Which side is correct? Please guide me. This side we can get the least position. Na? Otherwise, look at over here. If I move from the right hand side, sorry, left hand side, say, so I will have 1, 2, 3, and then 4. What is the carbonyl ka position? What is the difference? This way we are getting second position, but if I move from this side I will get the third position. Is this correct? No. So the down one way is wrong because rule says give the least position to the carbonyl group. Did you understand now? Selection of the carbon chain. Now name this compound, Hridaya.
Uh,
Root word, bute, single bond between carbon and carbon. So AN, what position double bond? Second position, ONE. It is clear? Now do this one. This is symmetrical, so no worry. Left to right to left. But you name this compound. Name this, Hridaya.
um,
5 carbon is spent.
uh, is it pen
Yes,
three?
pentane. Single bond hai na between carbon. So primary suffix you need to bother first. A and E will be dropped with the ONE. What is the position of ONE? ये 1 हो गया, 2 हो गया, 3, 4 and 5. What is the position of ONE, Hridaya?
Three.
Yes. So 3 ONA. It is clear now?
Yes, ma'am.
One more question. CH3, CH2, C double bond O, CH2, CH2, CH3. So the meth, eth, prop, bute, ये वाला line थोड़ा सा read ना by pent, hex. This is PNT pent, hex. ठीक है? The 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 and 6. Now you go ahead, Hridaya. How we do numbering? Left to right or right to left, Hridaya?
Left to right.
Exactly. Why did we go left to right? Because least position must be given. Na? So 1, 2, 3, 4, 5 and 6. Did you understand? Now name it. Name it by yourself.
X and B on.
Very good. So be confident. Very good. You have done. Did you understand the ketone? You still require some more example? Or we can go ahead with the carboxylic acid IPAC nomenclature. Can we?
Yes, ma'am.
Okay. So carboxylic acid is symbolized that CH3, COOH, right? So this side we will have arrangement like this. Okay. One compound, the first compound of the carboxylic as like aldehyde, we have for carboxylic also, it's called as the common name formic acid. What is the common name of this compound? Formic acid, which is present in red ant. Do you know about it? So this is considered as a one carbon. Now here to no problem. The first carbon terminal carbon है ना, तो that is called the functional group का carbon considered as a one. So one carbon है तो what do you name the root word? Meth. Carbon hydrogen, we do not have further carbon, so we consider carbon hydrogen bond. Single bond है so AN. E will be dropped with the suffix of oic acid. What is the suffix of this oic acid? Right now, what is the suffix of this? Oic acid. Is this clear? What is the IUPAC name of formic acid? Oic acid. So it is, no, sorry, methanoic acid. Is this clear, Hridaya? Now you go ahead with the next name. That other will be fine. I think you can do it. Remember meth, eth, prop, bute, pent, hex. Okay. 1, 2, 3, 4, 5, 6. Chalo. Go ahead, Hridaya. Carboxylic carbon is considered always first carbon. So how do we go for numbering? Left to right or right to left, Hridaya? Do quickly.
Is it right?
From
Left?
right to left. Very good. from right to left we should go, because carbon 1, carbon 2, carbon 3. Okay, now write the name. What will be the root word? 3 carbon है तो
Prop.
prop. Very good. Name this now. We don't have suffix over here. We don't have substituent. Prefix we do not have. Go ahead with the name, Hridaya.
Is it propanoic acid?
Yes, very good. Propanoic acid. Well done. So it is easy now. Next one, let us add one substituent. Okay. Substituents are not going to disturb us. Don't worry. 1, 2, 3, 4. You can go straight or you can bring down. No worry. So prefix number, prefix name, root word, primary suffix, secondary suffix, ऐसा rule follow करेंगे. Now you go ahead with the naming, Hridaya. Position of prefix you tell. This is the prefix and this is the functional group. Okay, this is prefix. So this will be written first. Prefix matlab which will be written first. And this is the functional group. Go ahead, Hridaya, quickly.
Is it for me?
Methyl.
Methyl.
Prefix always will be alkyl. Right? So 1 carbon है तो methyl, 2 carbon है तो ethyl, 3 carbon है तो propyl, as usual. Meth et propyl. चलो, methyl के बाद how many carbon chain? 5. Nope, not prop. Prop
Pent.
used for 3 carbon. Pent. Very good. Pent. How many single bond present everywhere? So A and E will be dropped by adding. What is the suffix Hridaya over here? Oic acid. So E will be dropped by adding oic acid. Is this clear?
Yes, ma'am.
Okay. Next one you do by yourself. Don't get confused. Okay. I have just open chain structure. I have it. Be confident. This is carboxylic acid. Go ahead now, naming, numbering, both the things you do and write the name. Yeah, Hridaya, what happened?
Is it 2 dimethyl?
Okay. 1, 2, 3. Very good. 2, 2 dash or 2 dimethyl. Very good. Dimethyl. Go ahead.
Propanoic acid.
Super. Propanoic acid. Good. So you got. Okay. If suppose if I take this compound and take CH2, CH3, CH3, CH2, CH2, COOH, then how will you name this? Select long carbon chain. ठीक है? Selection of long carbon chain, it's like a driving one way. We cannot go take turn and go back. ठीक है? One way है. So start numbering 1, 2. Selection है, responsibility. We can select this 6 carbon. If I go straight, I could have selected only 5. So this, if I go down and go turn, so it will be, this is my way. Correct. I haven't taken U-turn and gone like this. No, I cannot go and select this 7 carbon. No, not possible. समझ में आया हृदय? So how many carbons? Since we can select the long carbon chain by going down, we have gone, and these two are the substituent. Okay, so the circle one is the substituent. Write the name हृदय. 6 carbon है तो hex. Don't worry. Write the name. The circle are prefixes. Quickly हृदय.
Is it 4?
4, 4. 2 times we need to write because die is used. No?
Yes, ma'am.
No.
Dimethyl. Hexanoic acid.
6 is hex.
Hexanoic acid.
Hexanoic acid. Correct. So you are aware now about the IUPAC nomenclature? Any doubt in aldehydes, ketones and carboxylic acid के IUPAC nomenclature में? Do you have any doubt over there?
No, ma'am.
Okay. Now let me tell you, aromatic aldehydes, benzaldehyde, it is called as, what do you call this as? Benzaldehyde. You can also call the carbaldehyde. So if you have methyl present, you will call the methyl benzaldehyde, right? Methyl if it's attached somewhere. Now, if you have carboxylic group attached to it, what do you call this as? Benzoic acid. Correct, Hridaya? Aromatic ring में ketone if it is present, C double bond O CH3, you call it as a acetophenone. These are the name. Did you understand? Now, can we learn our chapter by the this shortcut route?
Yes, ma'am.
Okay, चलो. So the route shortcut में given है. I have already given the right hand side. I am taking you to preparation side of the um, aldehyde. ठीक है? So I will teach you the mechanism and all in detail. But the quick revision के लिए you have the chart with you. Okay, Hridaya? It is clear? This chart will be helpful to revise that. So preparation, first preparation, what is given that from acyl chloride. What is acyl chloride? We know what is acyl chloride. RCOCl. बहुत बार use किया है. We have used in acylation reaction. So R is equal to, if I take AR, aromatic ring ले लिया, तो no worry. AR भी हो सकता है, R भी हो सकता है. That is will be only acyl only, no change. So we have taken in the same way acyl because it is said that from acyl chloride we have need to prepare the benzaldehyde. So basically this undergo the reduction process. Okay, so palladium hydrogen का addition is reduction, correct? So carbonyl hai, we want hydrogen to be added and chlorine to be removed. So we have taken the same way here, the C double bond O, right, and the Cl. So we call it as a ArCOCl. It's a acyl chloride. ठीक. And then we have the hydrogen taken. Palladium is a surface providing barium sulfate ke presence mein. This is a catalyst actually. So catalyst is providing the surface. So benzyl chloride coming to on the surface along with the hydrogen and doing hydrogenation reaction. So hydrogenation reaction is simple. It what happens basically, hydrogen molecule mein HCl is going out and this hydrogen is taking its place. So what do you get as here? Benzaldehyde, C double bond O, H. So what is going out there? HCl is going out. Correct? Let me shade this part. Are you able to understand?
Yes, ma'am.
Second preparation is what is given as Stephen reaction. ठीक है ना? Second is Stephen. So what do you call the Stephen reaction में? Stephen reaction is the naming reaction. By name can be coming. Stephen reaction. So remember, Stephen reaction is the preparation of aldehyde. Aldehyde का preparation होता है from nitrile. So nitrile gives the aldehyde as the product. That is the Stephen reaction. So what other thing you need to remember? Reagent. What is the reagent? Then reagent will be the reducing agent only. That is SnCl2, stannous chloride in the presence of HCl. Did you understand now? Now do the reaction. Let us do. Nitrile ka symbol is Cn. This is nitrile, right? So we will take the RCN, we'll treat with this reagent SnCl2 in the presence of acid. What do you get as the product? The C triple bond N, it will be R C triple bond N. ये होता है arrangement between carbon and nitrogen, right? So this basically takes the hydrogen because it's a reducing agent, provides the hydrogen. Both will take the hydrogen and they shift the bond. Remember, always carbon will maintain its four stick. So if I have to maintain the four stick around the carbon, I would remove the one bond of the carbon and nitrogen will balance, it's a three stick. So only one hydrogen needed for nitrogen. 1, 2, 3, 4. Carbon ke around 1, 2, 3. Did you understand the structure, Hridaya? So carbon के around 4 stick रहेगा, right? 4 sticks and nitrogen के around 3 stick. Why? Because their valency is that. Carbon is tetravalent and nitrogen is trivalent. So that is their stick. Okay. So we have seen, we have shifted as soon as hydrogen enters. These are providing hydrogen to carbon nitrogen. So the triple bond which is present over here gets shifted. Okay, and they take the one hydrogen. So this is how double bond में convert हो जाएंगे, and we get the product as the reaction is there in front of you. We get the CH double bond NH. Did you understand?
Yes, ma'am.
And do we do the acid hydrolysis? Acid hydrolysis is very simple. जब भी कहा जाता है acid hydrolysis, that means you are going to add the acid into water. That means you have the H ion in a plenty number. Okay, that will be represented even by this symbol, hydronium ion. Hydronium ion ka formation, how do we get? When we add the hydrogen to water, we get the hydronium ion done. So this takes the oxygen. This is taken by hydrogen and this is taken by nitrogen. So hydroxyl group basically goes towards that side. So we get the product as over here benzaldehyde. I'm forming RCHO plus ammonia removes. Okay, Hridaya?
Yes, ma'am.
Okay. Any confusion in this understanding this reaction? What do you call this naming reaction as? Stephen reaction. Okay. Okay. Second, next reaction we have by naming again Attard reaction. So Attard reaction actually where we do the Attard reaction. Attard reaction basically for the preparation of the hydrocarbon, aromatic hydrocarbon. Okay, this will produce aromatic hydrocarbon will produce the benzaldehyde. Okay, this gives the benzaldehyde. How do we get? From the Attard reaction. So Attard reaction may we use the oxidizing reagent like chromyl chloride. This is CrO2Cl2. What do you call this as? Chromyl chloride. Chromyl chloride. So what is the function of chromyl chloride? It provides the oxygen to it. Okay, that's all. So we do in the presence of this. So little adduct product will be over here. How? Look at over here. Aromatic hydrocarbon mein we are taking toluene. You know about this? This is what? Toluene, right? Toluene will be treated with the chromyl chloride. What is the formula? CrO2Cl2. This is chromyl chloride treated with the carbon disulfide. This is the organic medium. Solvent act as, and this gives the product as over here. How many hydrogen do you have over here? Three, right now. So that adjustment, look over here. How do we do? One hydrogen co outside we keep. We'll take this along with it. Okay, we keep R, CR hai. O, the O2 will be arranged like it, sandwich form. OCRO. Got it? And then H will come in. One H will keep and then we'll make it two because two is missing from the CS3. One is already here with it. Correct. One is already here and two is missing from this. So two will be represented here. I will show how. Cl2 taken and we are going to do double of this. Means CH2 has been now associated with the CrO2 Cl2. Did you understand? This is the adduct product. So you need to little bit be very smart. Like यहाँ से we will do the CH and we'll do the CH2 को ऐसे remove करेंगे कि H we will write. We are just arranging this. We are making it OCrOCl2 and making two times. Why? Because it is H2. That is the reason. Did you understand? So this is the adduct product we get. Right, Hridaya? So no need to by heart anything. Everything is like depending upon the mechanism over here. Acid hydrolysis karenge, so whole part goes out and oxygen will be taken by this compound. So we get the benzaldehyde. That's all. Clear? So
Yes,
how
ma'am.
are you going to prepare this Attard reaction? You will understand that first aromatic hydrocarbon toluene prepares the benzaldehyde. Benzaldehyde is benzene CHO. For that you needed chromyl chloride. The formula is CrO2Cl2. So you will have this H3 को remove करेंगे, right? Two hydrogen will make the associating with the chromyl chloride in this order. So we want the everything to go out and oxygen to attach. So CH will be left over there. Oxygen will be attached after doing the acid hydrolysis. So we get the benzaldehyde. This is called the Attard reaction. Okay, Hridaya? One more we can do with the this hydrocarbon, aromatic hydrocarbon. This is actually the substitution reaction. Substitution reaction. Okay, so in this chlorine will be there, H nu will be reacting. So how many hydrogens will be removing? Because two chlorine had, the two hydrogen will be out. So when two hydrogen will be out, we get over here the CHCl2, right? So how many hydrogens are going total? Two hydrogen chloride is going out. We get the at that place. So we can understand the CH3, CHH2. So that H2 is going out, and that place is taken by the chlorine. That this is called the substitution reaction. Correct. Now acid hydrolysis, again same way. We do the water say hydrolysis, we get the benzaldehyde. Is this clear? So substitution, by substitution also we are able to do. Next is very important, naming reaction. Fourth it would be, isn't it? How many numbers we have done? No, it will be fifth. This is fourth. The fifth is Gatterman coach reaction. What was the Gatterman reaction, Hridaya? Gatterman में BDC, benzene diazonium chloride, when treated with the copper metal, it gives the, tell me the product. What product we get, Hridaya? Haloarine, right? So that was the Gatterman reaction. Now Gatterman coach, what is this? Benzaldehyde. Benzene say we get the benzaldehyde. So what do you get in this? Benzene gives benzaldehyde in Gatterman coach reaction. Benzaldehyde. Okay, Hridaya?
Yes, ma'am.
Yeah. So benzene is this treated with the carbonyl group. Okay, in the presence of hydrogen chloride and anhydrous aluminium chloride. Okay, so this will produce the benzaldehyde. That's all. This is called Gatterman Koch reaction. Two scientists are there, Gatterman and Koch. So this is Gatterman Koch reaction. Any doubt in the preparation of the aldehydes?
No, ma'am.
You can do it now. Now ketone can we study? So ketone ka preparation we have from acyl chloride. Okay, so you can go from acyl chloride. So here, if you remember, Hridaya, I told you acyl chloride, how it will be. Grignard reagent and the cadmium chloride. What is Grignard reagent? RMgX. Okay. It reacts with the cadmium chloride, which will be giving the dialkyl cadmium. What do you call this as? Dialkyl cadmium. This is what Grignard reagent. Is this fine? Shortcut.
Yes,
You
ma'am.
can understand. This is what cadmium chloride, right? What do you get as dialkyl cadmium? ठीक है? Once you get the dialkyl cadmium and this whole product Cl के साथ, this will go out. So we get the 2 moles of Mg. Why 2 moles? Because we have 2 chlorine over here. That's why. So we have to take this 2 mole because dialkyl is also prepared. So we get the MgX and the Cl. This is always gives the adduct product. Okay, out it will be. So R2CD we've got. Then now R2CD will be treated with the RC double bond Cl. So C, this will be going out. CdCl2. ठीक है? CdCl2 will go out and this R will come over here. So this also will be taken in 2 moles. So what we get as the 2 moles of R comes over here, this place. ठीक है? Suppose if I remove everything from here, what is left, Hridaya? R. R will come over here attached. Did you understand? So what do you get over here? C double bond is going, will bring it down. This is brought down. Now R will be attached to this. Now it is clear. So what do you get as the product? Ketone. And what is out? What I deleted? Cadmium chloride. This is out. Did you understand?
Yes, ma'am.
This is how the from acyl chloride. Okay. Next is from nitrile. So what is nitrile? CN. Okay. And what type of bond present between C and triple bond, right? So how do we do from nitrile? Look at over here. CH3, CH2, CN, and this is treated with the benzene MgBr. What is this? Grignard reagent. What is this? Grignard, you know Grignard reagent is RMgX. So R की जगह हमने phenyl ring ले लिया. Don't worry, it is AR actually. No problem. Correct. So we have treated this. So same way, the you, as usual, the reaction will go. If you don't want to write this product to be in a very direct manner, if you wanted to write, that also can be written. How it can be written? Remember, how did we learn that? cs3 ch2, if you remember, the aldehyde ke sath and ketone ke sath Grignard reagent reaction. So this part will come to carbon. ठीक है हृदय. Nitrogen will go out. Okay. And oxygen will come in. So carbon and oxygen bond will form as the carbonyl. Did you understand? Directly we can go for this. So carbon double bond oxygen and C6H5 will come down. So you can see 1 2 3 4 carbon has maintained its 4 step. Remove the nitrogen out, directly you can do this reaction. Did you understand? If you just connect yourself, the study alcohol में, how did we do the preparation of alcohol from aldehydes ketones? Remember, there the carbonyl group, it was converting into the OH, but here carbon triple bond nitrogen is getting converted. Nitrogen will go out. We will shift this. Nitrogen is being electronegative in nature. This takes the electron pair towards itself, and then carbon will have the positive charge. So C6H5 will carry the negative. This will carry the positive because electropositive hai. So when bond leaves, this becomes electronegative, this electropositive. So this goes to the carbon side because here positive and here negative charge is present. Did you understand? And we are removing nitrogen completely. So when we remove the nitrogen, iski jagah pe kya aa jayega? Oxygen after hydrolysis. So this is followed by the acid hydrolysis. Remember, is this clear?
Yes, ma'am.
This is from nitriles. Then from substituted benzene. Substituted benzene is easy. We can take the benzene compound, okay, and we take the CH3COCl, right? And what is this called as? Acylation. Yes, remember Friedel-Crafts acylation reaction, isn't it, Hridaya?
Yes, ma'am.
So what do you get over here? This part, CO gets attached to this carbon and here's a hydrogen goes out. So we get COCH3. What do you call this as? Acetophenone. COCH3 with benzene is called acetophenone. This is Friedel-Crafts acylation reaction, right?
Yes, ma'am.
Next, carboxylic acid preparation. This way it is easy na, to prepare the chapter. Are you finding easy or not?
Yes, ma'am.
We can finish it quickly. Okay. Now, how do we prepare? See, 1 degree alcohol can also be converted. If you remember, I said 1 degree alcohol ka property is CH3CH2OH hai. ठीक है? This can be treated with the KMNO4. Remember, it provides the oxidation. So this goes to CH3CHO and then again further KMNO4. So it is all oxidation process. So oxidation reaction. Remember? So that is the reason I said you have to connect this aldehyde, ketones, carboxylic with the alcohols chapter. It's very important. So the property, it's vice versa. That's all. So CHO will go to carboxylic acid. They do not gain any carbon, just they gain oxygen. You can see number of carbons same as usual, 2 2 2, but there will be in each step addition of oxygen. यहाँ पे hydrogen, now we can see hydrogen is getting removed, so I'm preparing it for the addition of other further oxygen, so one more oxygen get added. Is this clear?
Yes, ma'am.
Okay, same way we can do from alkyl benzene. What is alkyl benzene? Actually, they have just tried to confuse you. This is actually, what do we call that? Toluene. ठीक है ना? You know about it? It is a toluene. So when you treat this with the KMNO4 and use the KOH, basically it's oxidizing. So K also goes over here. No worry how many hydrogen it does hold. Always And how many carbon? Let me tell you the best part with this. Suppose if I take hydrocarbon, a long carbon chain, if I take CH2, CH2, CH3, doesn't matter, Hridaya. So with the same reagent, if we get the only one carbon holding compound. Are you understanding? See, we have one, two, three carbon, no? Doesn't matter. What we get over here as the one carbon. And then directly what we do, acid hydrolysis. So yahan se when we do the acid hydrolysis, HNOH, KOH comes out, ठीक है, and H चला जाएगा इसके पास. So what you get as the product? COH, benzoic acid you get. Did you understand? And the same way you get over here also acid hydrolysis, and you get the benzoic acid. That's all. Easy.
Yes, ma'am.
Next. So reactions are simple only, but we have a trick to understand that so that we can make it easy now for us. So next is the nitriles and amide ke sath we can have. You can see the nitrile and amide mein what is happening. R triple bond, C triple bond, and we have. Okay, that is called nitrile. Now you must be aware about the nitrile. What is nitrile? CN is nitrile. So acid hydrolysis we are doing H3O plus, H plus and OH minus hai. So basically this bond will shift towards to nitrogen because nitrogen is being electronegative. This will shift. Carbon acquires the positive, this acquires the negative charge. So H will go to carbon side, correct. Sorry, oxygen will go to the carbon side, oxide ion, and N will have the hydrogen with it. So what you get over here as the product is C double bond O NH2. So nitrile converts to amide. This is called amide, right now? And then amide ka we do the again acid hydrolysis, and what you get over here as the, see, NH2, we are having two hydrogen atoms, so again the bond will be cleaved here, and this takes the R C double bond O and OH over here. So carbon will become carbon positive, so OH will go over here, and this takes the electron out, so this goes out, NH3, so hydrogen will be taken by it. So what do you get as the byproduct? Ammonia as the byproduct. Easy?
Yes, ma'am.
Mm. So this is from the nitrile. The next is from the Grignard reagent. How do we get the from Grignard reagent, Baba? No worry, Grignard reagent is RMGX. Okay, it gives the adduct product always. So we get the carbon double bond oxygen. Okay, so carbon dioxide hai. So we have this carbon ka. Now this is plus, this is minus, and oxygen will be having one pair towards itself. So carbon acquires the positive. This is negative. Now this part will come and attack over here. This part will come and attack over here. So all will start. So we get the carbon ke saath R. You can see how R is getting attached. OMGX. Did you understand? And other side mein, if you wanted, you can keep the other side oxygen as it is. Mere saath ulta hua. I have kept this side, and that in the diagram it is kept ulta, right? No worry, we can, you can understand na. Then acid hydrolysis, same Grignard reagent ka process, H plus and the OH minus. So H plus will be, see, electron pair moves over here, so this will be taken by this because this carries negative ion. And over here we can see the bond which is having between oxygen and hydrogen. This takes the electron pair, carbon and oxygen, this takes the electron pair towards itself, so this carries the positive ion, right? So OH will go towards this carbon. So what do you get as the product? R, C, right? OH and, sorry, just a minute. Hridaya, 1 minute. Huh? Give me a minute. No need to convert this because H will, if it comes, will be OH turning, right? And this will be, so let us shift here. 1 minute. Little change over here. Because seeing this, it will not be applicable, right? So what I will do over here, Hridaya, let this bond, okay, to be as it is, okay, and this bond will be cleaved over here, so we can have mgx out. Mgx will take the positive, this will take the negative. Now let the H go over here and OH come over here. Did you understand now? So we will have double bond as usual, and O takes the hydrogen, so carboxylic acid, and we get MgOHX. It is clear there now?
Yes, ma'am.
So this is from the Grignard region. And next again from the acyl chloride. Acyl chloride one to easy. You could see acyl chloride के साथ RCOCl, OH attacks. So HCl goes out and RCOH. Same hydrolysis we do. We get the carboxylic acid. And same applicable for esters also. So these two last reactions are simple one. Esterification and all. Properties can we have now?
Yes, ma'am.
So in this properties, aldehydes and ketones both are taken together, Hridaya. ठीक है? Why it is taken? Because if you see the structure, look at over here, both are having almost the common structure. What is common in these two? We can say this group, right? RR. The other side you have in ketone. So if we don't keep R and just take the mechanism carbon double bond oxygen के साथ, so it will be a common because carboxylic के साथ we have one problem. It contains the hydroxyl group. Correct. So we cannot take carboxylic together along with the aldehydes and ketones. Correct. That has to be taken separately. So that basically the property is in this order. Understood? So aldehydes and ketones, they both contain the carbonyl group. What do you call this as? Carbonyl group. Is it clear, Hridaya?
Yes, ma'am.
So let me tell you in the property may what again the mechanism part is important over here, Hridaya. It is important and very simple also. You could understand by just seeing how the addition is happening. See the first one, I am taking you to directly. You can read the first boiling point is higher than the hydrocarbon ether comparable molecular mass because molecular mass is higher here. Correct. So it will be high. Solubility, we do not see the in lower one will be soluble, but higher one will not be soluble because intermolecular hydrogen bonding will not be formed. These all we have done, right? Let us come to the mechanism, chemical reaction. So that follow the nucleophilic addition reaction here. The nucleophilic is easier than, sorry, addition reaction is easier than substitution reaction. Addition may what happens, it will be just a shifting of the bond, okay, and it will form a nucleophile attack, that's all. So what do you get over here? This gets cleaved, you get the H2O and Cn minus as the electronucleophile will be generated. You get H2O over here. Did you understand how the nucleophile is generated? This is called the nucleophile. Nucleophiles are the reagent molecule, anyway you can call those who are holding extra pair of electron and they get attracted towards to the nucleus. Clear?
Yes, ma'am.
That is why nucleophile, nucleus loving. Nucleus holds the positive charge, so they themselves carry electrons. That is why they get attracted towards the positive center. Right, Hridaya? Now here, when we write the mechanism of general, in general, when we are talking carbonyl plus CN will attack, so it is understand over here now, this will shift. So this will generate the partial positive, partial negative. Where the cyanide will attack to where positive ion is present. So when this attacks, we get the product as over here. Look at over here. CN gaya, right? The ON minus CN comes over here and these two groups aldehyde hai to we get other side R. If we have ketone, RR. Did you understand?
Yes, ma'am.
Yeah. So this is the mechanism. Now adjusting this, we need to rearrangement. So rearrangement mein what happens? This gets the hydrogen. Okay, that's all. So we call hydroxide. Okay, clear there? You can understand?
Yes, ma'am.
Ketone ketone gives the glycol. So you can see here R C double bond O hai R we both with the sides we have plus it is with the glycerol if you react show the compound. So oxygen opposite side means we are taking oxygen out and OH out. Okay. So sorry the two H2O. So these two hydrogen and one oxygen will go out. So how the bond will be formed? Carbon, okay, O O, these oxygens are connecting CH2. Just make it ulta, opposite side. Bring the CH2 this side. So single bond and R as well. That's all. And plus, as I said, 2 hydrogen, 1 oxygen will say H2O. It is clear?
Yes, ma'am.
Now, naming reaction given, I will brief you here. The two naming reactions we have, Clemenson and the Wolff-Kishner. Clemenson reduction reaction and Wolff-Kishner में क्या difference है हृदय? Clemenson is used zinc amalgam. ठीक है, zinc amalgam with the hydrochloric. Wolff-Kishner is not used that reaction. Wolff-Kishner reaction, reduction, both are reduction actually. So this reduction process में, Wolff-Kishner reduction में, we use the reagent as the, if you remember, the one reaction we have done the ammonia derivative. I'll take you in the chart after finishing this. Okay. So you say the hydrazine is taken. This is called the hydrazine, right? It is hydrazine. Okay. It's a ammonia derivative. Hydrazine. Hydrazine ka we have learned the process. Hydrazone will be formed, carbon double bond nitrogen, and then it go for the further KOH के साथ ethylene में we will take the medium and just heat. We get the same product what we are having over here, but via different way. Did you understand? We get the same product. What are you getting over here? The reduction may learn over here. Carbonyl group converts into CH2. Did you understand? Both the products are same. Product P will be common in both, but via different way. This is our P. Did you understand? Both the reductions are producing same product, but via different. Did you understand what is Clemenson reduction? If you have the carbonyl reaction with zinc amalgam and hydrochloric, this is Clemenson. But if you have with the hydrazine and then you can have this KOH ethylene reaction, then you can say that is Wolff-Kishner reduction. Okay.
Yes.
Okay, Hridaya. Now, oxidation reaction. Oxidation reaction to only for the, this need not to by heart, Hridaya. Reactions, I will tell you, you have words के साथ. So, यहाँ पे you will make the chart, oxidation reaction. So oxidation reaction shown with the strong oxidizing reagent. Okay, pehla strong oxidizing reagent. What are the strong oxidizing reagent? KMNO4 हुआ, ठीक है, K2Cr2O7. These are in all the medium, acid, basic, and the neutral medium. They do react. Okay, so they provide nascent oxygen and they get oxidized. So what happens basically, aldehyde jo hai, that gets oxidized very easily. It gives the carboxylic acid. Okay, it gives the carboxylic acid. What happens to ketone? Ketone, will it produce some compound, right? So no, oxidation reaction is not possible with the ketone. Even with the mild oxidizing reagent, if we are having mild oxidizing reagent, look at over here, mild oxidizing may you can use Tollens reagent. Okay, you might have done all these reaction, no? Fehling solution reaction in a viva, Fehling solution reaction. So no one result we can say positive with the aldehyde, but negative with the ketone. Ketone does not show this reaction. It is clear, Hridaya?
Yes, ma'am.
You might have studied na reaction with Tollens reagent as well as Fehling solution. So here you must know for 1 mark question, what is Tollens reagent? Silver ammonical nitrate is called silver ammonical nitrate is called Tollens reagent. It is for a 1 mark question. Very, very important. What is Tollens reagent? Silver ammonical nitrate is Tollens reagent. It is a distinguished test to distinguish aldehyde and ketone. You can write in your word now. See, Fehling also used. Fehling is A and B combination. A is copper sulfate solution. Okay. And B is sodium, potassium, and tartarate. You know, tartarate present in tamarind, tartaric acid. sodium potassium tartrate. So this combination we call as the Fehling solution. Ketone does not show any reaction. Okay, what happens when aldehyde treated with this? Aldehyde show the decolorization. It shows the color change. With the Tollens reagent also gives the silver mirror. So it gives the positive result with both the reagent, mild reagent. Did you understand? But ketone does not show any reaction with the Tollens, with the Fehling, anything. Is it clear, Hridaya?
Yes, ma'am.
Okay. Now the haloform reaction used for ketone. Haloform reaction. This reaction is specifically for the terminal methyl group. Terminal methyl group, which is possible with only ketone. See, both the sides you have methyl, methyl, no? One side you have hydrogen, other side you have methyl in the aldehyde. So aldehyde will not go for this easily, whereas ketone easily go for the haloform reaction. Got it? This is how we can distinguish. So if they ask how to distinguish propanone and suppose one more यहाँ पे add कर लेते हैं hide carbon, so this will become propanol. How will you distinguish propanol and propanone? So by using haloform. Haloform में iodo ले लो, iodo form बन गया. Did you understand? So iodoform test is positive with ketone, negative with the aldehyde. Why? Because there is a terminal methyl group. Can you understand? Seeing the reaction now, Hridaya?
Yes, ma'am.
So this is the another, sorry, distinguish test to distinguish aldehyde and ketone. Got it? And chalo, we are learning now aldol condensation and Cannizzaro. So this is for your long mark question, long question. Aldol condensation. What is aldol condensation, Hridaya? Which type of aldehydes will go? Which has alpha hydrogen, right? So formaldehyde, will it go? Tell me, formaldehyde, will it go? No, no. Why? Does not contain alpha hydrogen. See, this is formaldehyde, does not have next carbon, na? It has hydrogen. So if you have after this carbon, then it is called as the alpha carbon. And the carbon hydrogen present over there, that is alpha hydrogen. So as any we can say this is, see, this is next carbon is alpha carbon. So if this is hydrogen, so it contains alpha hydrogen. So this will go. Here the alpha hydrogen present, here absent. Is this clear, Hridaya?
Yes, ma'am.
So compound must contain alpha hydrogen. Then only you can say that will go for the aldol condensation reaction. You can see the reaction aldol condensation. 2 moles of methyl uh, means acetaldehyde is taken. It is treated with the dilute NaOH reaction. So the combination of the 2 methyl means aldehyde. कैसे होगा? Look at over here. So very simple. Whichever compound you are taking, Hridaya, here, the first one or the second one will undergo the change. ठीक है, यहाँ पे what you have aldehyde का symbol, this, correct now? So what we get over here as, think about it. You get this bond shifted. ठीक है, this gets the positive ion, this gets the negative ion. Now from here, similarly, from here, one hydrogen down and 2 hydrogen over here, C double bond H. इसको ऐसे ही रहने देंगे, we are not. यहाँ पे ये hydrogen will move out in the form of proton. So proton will go attached to O. ठीक है? So this what it will produce? CH3, C, ठीक है? OH यहाँ पे बन गया, और यहाँ पे what we have the H is already gone na, so we will have the CH as usual, we'll take it, and then further it is connected with this carbon CH2 and then CHO. Did you understand the mechanism? Once again you want me to teach? Tell openly, no worry. Once again? Okay, I'll teach big थोड़ा बड़ा बना के दिखाती हूँ. So what is aldol condensation? The condition you have understood na, compound must contain alpha hydrogen. ठीक है, इसके बाद we'll take some break and then we'll start amines. Okay.
Yes, ma'am.
Okay. Now you can prepare as your because polymer is not no needed for the revision, because polymer is all the things, it's only your theory part, right Hridaya? I'll teach you the Haworth structure, because Haworth molecules needed the trick. Other thing is theoretical, you can study by yourself. So today task will get over once we are done the amines. Okay.
Yes, ma'am.
Yeah. And after that, you can prepare by yourself. Tomorrow, whole day, you can do preparation. Okay. And we'll
Yes, ma'am.
connect in the evening time with your doubts, clearing your
Yes.
doubts.
Yes, ma'am.
Okay. So the trick which I have shared you, please use for the preparation of the organic chemistry. Hridaya, definitely it is going to help you. Have confidence. You have all this stuff with you, knowledge with you, you prepare. Let's learn how we go for the aldol condensation. Aldol condensation reaction. Condensation means we will heat it at the last and we'll remove water molecule from it. That's all. Before, because we have the reactant taken 2 moles of acetaldehyde. So I am taking acetaldehyde in this way. Okay. Plus I am taking over here this another acetaldehyde. This is understood na, Hridaya? So now what I am going to do, Hridaya, look over here. This CH3, I am going to make CH2 and hydrogen. I'll do slowly, don't worry. And then I will shift this bond towards oxygen. क्यों हो गया shift? Because oxygen is electronegative. Always electronegative atom will take the electron towards itself. ठीक है? Electron will be taken by the oxygen है, nitrogen है, fluorine. These all the electronegative atoms. So they take electron pair towards itself. What is shared between them? Okay, clear?
Yes, ma'am.
This much you understood, no? So when this shifted, what does it carry, Hridaya? Negative. And I said that this goes out. Okay, clear, Hridaya? When this shifted, carbon takes the positive ion and oxygen takes the negative ion. ठीक है, and now this carbon is taken the hydrogen out, given the hydrogen out, so pair goes towards to carbon, because hydrogen does not take its electron with it goes with the electron poor nature, hydrogen plus. So now what you can think, Hridaya, carbon will get so yahan attachment hoga, they get attached. It is clear now? Did you understand?
Yes, ma'am.
And now this hydrogen is free, where will it go? This will go attached to this. Now did you understand? अभी सबको हम अरेंज करेंगे. हाउ? I will take this CH3 first. Okay. Then I am taking CH. Okay. Then I am taking O and H over here. So OH. This much is understood. Now this bond I am taking, Hridaya, this bond. So single bond CH2. And then this part. Did you understand? Now is it clear?
Yes, ma'am.
Okay, Hridaya. Now we are going to do the condensation. Condensation के लिए क्या करेंगे? We'll boil it. Okay, we'll make it vapor form. So vapor form में you understand the CH2 I'm going to again the rearrangement part. यहाँ पे H2O I will remove. Condensation में this goes out. So oxygen will take the electron pair towards itself. Hydrogen will not take. Hydrogen go away like that only without electron. So this electron pair will be shifted between these two carbon. So whenever we have the methyl CH3 CH double bond, wherever OH है ना, वहां के next carbon पे double bond आ जाएगा. Remember, this is the trick. So you get this is the product as aldol condensation. समझ में आया? Did you understand?
Yes, ma'am.
Okay. So same rule will be applicable with the ketone also, and the cross aldol condensation also goes the same order. Cannizzaro reaction is opposite of the aldol, Hridaya. What is Cannizzaro? Cannizzaro means does not reaction will be taken does not have alpha hydrogen. Now, formaldehyde is applicable. Acetaldehyde won't be. The carbon, this hydrogen hai hydrogen. So यहाँ पे no carbon, right? So we can say this is the compound does not have alpha hydrogen. What is this compound name? Hridaya? Formaldehyde. It is clear?
Yes, ma'am.
Formaldehyde treated with the any alkali compound, NaOH हो गया, KOH, 2 moles will be taken. So this is also again simple one. We'll shift over here. 2 moles we have taken. So 1 mole say we get, remember this, 1 mole say we get alcohol product. And other mole say because it is CH3, so 1 hydrogen comes over here. So we get alcohol as the product. And Na hai to we get the HCO, HCOO Na. K रहेगा तो if we have KOH then HCOOK. Did you understand?
Yes, ma'am.
That's all. Easy. Electrophilic substitution, so we have a simple one because it's a just it change the product Hridaya. Here will be the they have printed wrong. Aldehyde hai, aldehyde ka reaction with the HNO3 they are making with H2SO4 and the product they have marked wrong. CHO ke saath will be NO2. I don't know what they have marked. C2N they have marked. Just you correct this, misprinting it is.
Yes.
Right? Okay, Vidya. Carboxylic acid preparation you say where see whichever you are not understanding, let me know. It's easy, all the reactions are. Nitration mein what happens? We get the nitro group attached to that, right? Red phosphorus when we are taking halide gets attached. All these we have a reaction I studied in Hello Erwin and Hello Alkane chapter. See these reactions, whichever you are not able to understand, tell me that I will teach you. Carboxylic acid because carboxylic acid is easy. Direct substitution we have in carboxylic acid. The first is the esterification. You know about it, na? RCOH plus ROH. Carboxylic with the alcohol ester formation. PCl5 again the OH goes out. So POCl3 you get and the HCl you get. You get the acyl chloride. Ammonia के साथ reaction you get the amide production. Then we carboxylic acid B2H6 means the diborane के साथ reaction you get alcohol. Then sodium compound with this is decarboxylation. We have done yesterday, but once again I am teaching you. This is the compound Hridaya. I am doing the this reaction. Can I mark and show? Send you once again which one I am doing. Are you able to find out which reaction I am doing?
Uh,
No? I'll mark you, mark
yes.
and send you. I have marked in the green color. Did you see that?
Yes, ma'am.
Okay. So this is what COONA soda lime, NaOH in the presence of calcium. Yesterday we have done Hridaya. So what it will be giving? These whole product will be coming out and we have R and H ka attached. So what you get as hydrocarbon and sodium carbonate is out. Alkane is formed. So what happens when CH3, COO, Na, NaOH treated with the CaO? Tell me Hridaya, what do you get as the product, main product? इन सबको निकाल के बाहर फेंको. What do you get as the product? CH3 plus H becomes CH4. So what do you get as the product, Hridaya? Methane, right? Easy? So this is called the decarboxylation reaction. What do you name this as? Okay? Clear, Hridaya?
Yes, ma'am.
The last one is easy, red phosphorus and nitration. And we have learned the IUPAC, and structure is easy. You can understand the structure. Middle one, aldehydes and ketone. All we have done, the IUPAC name and all. Correct? Have some break, and then half an hour hardly needed for amines, Rubia. Okay, like this chart I will send you. Okay? Any confusion you have in any reaction now, openly you can ask. Don't worry. Don't hesitate. Once again, you can ask. Just go through with the all reaction which you have chart with you. Any confusion in the chart or learning the property preparation you have, you can ask me before going in a break.
No, ma'am, no.
No doubt. Pakka?
Yes, ma'am.
Okay. So have some break. How many hours do you want? Half an hour, 1 hour? How many hours?
Well,
1 hour you want?
mm,
Chalo. 1 hour के बाद we'll connect.
ma'am, if the remaining can be finished in short time, then we can do it fast. So,
Sorry, Hridaya, what happened?
ma'am, you said that after this it will only be half an hour class or little more than that. Right?
Yeah. Half an
Then
hour
we
class.
can
Because
have a shorter break also.
after this, you want the short break, amines to be completed.
No, ma'am, I'm saying if the remaining class time is less, then the break also we don't have to have big break. We can have a small break and then continue.
Okay, no worry.
Yes.
Okay. Because one class is there with for me. So I am just looking for the link. If it is being shared, then I will extend your class for this amine ke liye. Is it fine to you?
Yes, ma'am.
Huh? Till then, you can prepare your organic. Okay.
Yes, ma'am.
Just go through with that. Any topic which you are not able to understand, you can ask me. I
Yes.
have shared you all the summary, everything. Anything needed, still you can text me. Feel free. Okay.
Yes, ma'am.
Yeah. We'll connect again. Just let me know when you are free. I'll just finish my meeting. One meeting is there. I'll
Oh,
finish and text you. Now I am
yes.
available. You can have break. Yeah. See you,
Yes.
Shraddha.
Thank you, ma'am.
Thank you.
Yep.